Today we'll talk about Apache Iceberg and then a bit of Snowflake, and then there are a couple tutorials that we can try to do. On my account with multiple connections, the only restriction we have 400 credits. The credits we only pay if we running the query. For example, this is I just go to worksheets and open getting started with tutorials folder. It basically give us UI like tbeaver, but from the browser. And here we can run the Python or we can run the SQL. And there are two main things in Snowflake is the roles and warehouse. And role is just list of permissions. And then every time then we are running tab, for example, then we execute the query. We here usually need to specify role because role attached to the user or user attached to the role, and it will tells you, do you have access to do what you want to do? For example, do you have access to query data? Do you have access to write into database or drop the tables? And that's why you need the roles. And it's very similar what's happening in the BI tools. You also have the roles or even in public cloud like AWS Azure. The roles is just list of permissions that you might have, for example, policy in AWS or Azure and attached to the role and user attached to the role. Here we don't have the policy, which we have privileges, but the idea is the same. And account admin, there are different kind of roles available out of the box, like account admin, org admin, security admin. They have different permissions, and you even can go to here to administration and you can go users and roles. We have one user that I created. We can see default role of the user, default warehouse. Warehouse is just virtual machine, or it is like cluster of virtual machine. It has two roles. They're here. Yeah, account admin and org admin. And usually then you work with Snowflake and you want to build security model, you want to create roles. For example, you create database. For this database, you can create admin role, like developer role and viewer role. For example, you create the warehouse, and for the warehouse, you can also create different kind of roles. This is the warehouse. It's currently running. Then it's running, it's burning the credits, and the warehouse has the size. This is how much how long it's running, and how much credits we spent. It has one cluster, size 6 small. It doesn't really have even details what's inside, but if we Google documentation, we'll find out. If I go to here, in this tutorial, yeah, we can use the role, the warehouse. It's already here. It's the same if I will choose it from here. And then we will create a new database. Inside database, we'll create a new schema, and we're gonna create a new table. Table is empty, we just created. If I refresh it here, you see I have the new database. By default, it has information schema in public, and this is what we created, and we have table. Currently, this is storing and managed by Snowflake. Despite the fact that this is Snowflake is on top of AWS, every data that we'll have, the data will be stored in S3 bucket, but Snowflake works in the way that we don't have access to S3 bucket. We're not able to see what is inside this S3 bucket, and you can think about it's the same as like Postgres, or you just load the data sits inside database. That's how works perception of Snowflake. And then what we're doing next, we need to create the stage. The stage, it's a kind of like abstraction of on top of S3 storage. If you never work with S3, it's like Dropbox, Google Drive, storage, object storage, there you can store the files. And usually then you have Datalake, lakehouse, This is where you store your data, and then you bring your compute. It could be Spark, it could be Hadoop, Hive, or something to query the data. The stage in Snowflake is just abstraction that will connect Snowflake to S3. Because it is Snowflake, then we create Snowflake, it also has own S3 bucket. There it's like organize all the data, but we don't have access. And the data is storing there in own Snowflake format. It's using micro partitions to work it fast, but we don't have access. And Snowflake has options to connect external S3, and we can build external tables, similar like Athena or Trino. Then you have query engine, and you can query external folders. Yeah, we created. Now we can, then we create this stage. We basically attach stage. We're attaching this S3 bucket to Snowflake, and then we can list what's inside. We see there is one file, right? And it's quite small file. Next one, same as Redshift or like other cloud databases, we can use copy command. The copy command will take this file and push into Snowflake storage. And if you will think about ETL versus ELT, this is ELT. It means we have the file and we just load this file as is, like the whole file, into Snowflake storage. And then you can do the transform, like run the queries or connect the DBT and do transform. That's why it's ELT. If you think about ETL, it would need some kind of tool, or maybe even just the Python that's running from local machine that will read this file and then inserting rows. You have some external processing thing, could be Python, could be anything, and it's reading the file row by row. Then it's ETL. If you just push file as this, you could also say this bulk load into database, this is ELT. Okay, and now if I run this, and here you see, instead of showing like S3 path, I showing the name of my stage. It's loaded, and it tells me how much things it's loaded. And it means now we have the data and we can query it as usual. That's a kind it, and it means that we have this table. It tells us the columns in the table. We can go open, see the definition of the table. We can add even description, columns, data preview, the copy history, the information, also who is the owner of the table. Another nice thing in Snowflake, it has built-in options to build the dashboards. I will show you just a moment. But what else? So if you go to admin, go to where cost management will trying to tell me over the time how much credits I spent, and usually one credit costs $2. So then you can multiply. Okay, user roles, data. Maybe I need to go to data. Data. I forgot where is the stage leaving. This is the monitoring tab. Here we can see history of all queries by users or by anything. We have separate copy history. If you want to go and see, I don't know why it doesn't have my copy thing yet. Snowflake have tasks, means you can create some steps or transformations or like procedures and schedule inside Snowflake. It could be like the whole platform to running your ETL. That's the type. Task. Dynamic tables, I think it's using for streaming use cases. If you have some kind stream with Kafka, usually in data warehouse, it's very hard to stream data because it's usually only batch, but the dynamic tables allows you to hook the data and stream inside the table. And then, for example, you have fresh data in real time almost. Logs, trust center, I don't know. Warehouses we check. This is users and roles. Accounts, security. That's interesting. I like this. For example, if I connect GitHub or Fivetran or BI tool to Snowflake, and I'm using the users, and usually then we're using the user we have user and password, but there are more safe way, for example, using user and key value pair. We have like user and SSH key, but also with network policy, you can limit IP addresses where the request is coming from. For example, if you're connecting Sigma BI, then I know the Sigma IP address and create the policy here and restrict it only Sigma. If I using Snowflake in my CI process in GitHub, then I can create policy with IP addresses and limited it. So that's very good. And also it has many other security things, for example, dynamic masking. So you have some PI data, it means like customer email and so on. Then you can create rules to mask the data. If the person doesn't have the access, their role doesn't have the access to personal data, it will hashing it. I'm not sure where we define the stages. And Snowflake also give us sample data, and this is known data TPS CH SF. It's known data set for benchmarking. If I go here, this is the website. It provides data sets like databases, tables, and schemas. For example, Snowflake wants to tell I'm faster and cheaper than Databricks. They both can use the same data set from this provider. What Snowflake did, they multiplied. There is like really little one, but there is also the huge ones. I go here and we see the biggest table we have here, 159. What's about this one? Oh, here we have the table, 10 terabytes. You want to work with kind of like big data, then you can do benchmark testings and trying to see how it's gonna work and how much it costs. But obviously, if you want using query 10 terabytes of data, you need to create warehouse much bigger. For the warehouses, if we go to warehouse and we decide to add another warehouse, this is the size we can have, right? And you see, currently we're spending 1 credit per hour. It means if I have 400 credits, then I can divide it by 2 if I have just single warehouse, and we all can use this warehouse. It's will be like 200 hours. It's less than 10 days running nonstop. And it has auto terminations. If no one used the warehouse, it will just stop it. Here anyway, I have just these 400 credits available for 30 days. And after this, it's going to expire. That's why you now have, while it's active, you have good time to go and try any other projects that we have here. For example, this one, dbt core in Snowflake, or Snowflake Hex, or Soda core Snowflake, that you can go and try them, or even like Iceberg tutorials or any other tutorials on Snowflake. That's good opportunity you have for 30 days. Also, what it has here, it has AI ML Studio that I never used, but it even has available generative AI model, and you can use the forecasting. Because it has the Python, first of all, you can query all the data available in Snowflake and build your models and host the models. I know they introduce containers, means if you want to host your machine learning model, you can have the containers and host the container with the model. But I never did this. Document AI is the new service that can work with PDF documents to parse it. About data products, it has a bunch of different products, apps, and I don't know what they all doing. Some kind of integrations. For example, if I click DBT Labs, it's maybe, yeah, the marketplace. We can build direct integration with Fivetran or DBT or Sigma. From here, we can launch the instance of Fivetran, DBT Labs, Matillion, like Tableau, something. Try. Also, it has different data sets available. The whole ecosystems exist. So we can create the app, and we can use available app. built. Maybe in free trial it's not available, but the Snowflake has available Streamlit. Streamlit is a kind of like Python web library. You can create, for example, BI dashboard, the custom BI dashboard on top of Snowflake data. You can query the data in Snowflake, kind of like in data frames, and then pull different visualization charts and able to create some kind of like dashboards and apps for users for the custom. And it's open source Streamlit, but Snowflake I think bought it, and it's available right from Snowflake. Yeah, maybe it's not available for me to create it. The sharing data that works in the way that you can share your databases with other customers of Snowflake, and they can share it with you. For example, if one organization and another organization both using Snowflake, you can share it. What is provider studio? I don't know. Partner, yeah, the partner connect is actually what I told you about integration with BI and ETL. So here, other features of Snowflake, it's zero clone. If we go to data and I have, for example, here, I have the table, the size of the table on 1 terabyte. I can clone this table with 1 second. I can just run create new table as clone this one, and Snowflake will create the copy of the table instantly without physically moving the data. For us, it will be two absolutely different tables. As soon as we clone the table, we can start working this, modifying, do what we want. This is zero cloning. In other things, it has the time travel, but now it's not new feature. Everyone has the time travel. It means you can, assuming I drop the table, even 1 terabyte size, I can write undrop command, this table will come back. Or I run update statement and change a lot of inside this table. I can check the history of this table, like snapshots, and I can pull data from the past. I can compare with the current one, or I can just restore it. The same like GitHub commits, you can revert commits. Here you can do the same changes, but time travel costs money. It means you need to actually physically store copy of your data. I mentioned that we pay credits for compute. For storage, we also pay. All data that managed by Snowflake, like we paid the same price, for example, as free cost. It means Snowflake paid for us and we pay to Snowflake. That's why the cost consists from compute using and storage. That's enough for Snowflake. And then, yeah, if you want to explore it, you can, or a bunch of tutorials. Now, I want to talk about Apache Iceberg. Traditional use case with Snowflake, it's clear. With the data warehouse, you want to consolidate the data all together. And you can, for example, use different ETL tools to ingest the data into Snowflake. Then you, very popular case, using dbt to transform it and connect to BI. Or you can use Python, do everything with Python. That's not common with Snowflake, because if company have money on Snowflake, they probably don't want to use plain Python to run it in Airflow, do everything. They can use open source tools. They can use some other kind of tool, maybe commercial tools. I think one of our project was somewhere that we used Fivetran to ingest the data into Snowflake and then dbt to transform data. That's the most typical use case for Snowflake. On the other hand, some organizations, they're using Datalake. And with Datalake, for example, you decide, I don't want the data warehouse, I want Datalake, especially in the past. Then we had two different products, data warehouse and Datalake. And we had such big data that we decided, okay, we want to store data inside storage. On premise, it's HDFS, but I will talk about cloud, for example, S3. The data will be stored in Parquet or org format, and you have compute engine and you have your metadata like hivemetastore, and this is your data lake. You completely split your storage and compute, because traditional data warehouse like Redshift, Teradata, Oracle, you couldn't split storage and compute. The Snowflake, you can split storage and compute. The biggest feature of Snowflake is data warehouse, but you can split compute and storage. And if you know what does mean lakehouse, I think the Snowflakes, it's more lakehouse versus data warehouse, because it's split at your compute and storage. You have virtual machines and the storage. You just don't control the file format. If we go here, we can quickly go through some difference of fundamentals of Apache Iceberg. And here they starting, if we discuss the analytical workloads, then typically it consists from, like, if we look to any kind of like storage systems, it consists from the storage where we store, there is the file format. It could be, CSV, parquet, it's table format. And there is storage engine, compute engine, and catalog. Those components of any storage systems that we're working now. And then depends on what we're using, data warehouse, data lake, or lakehouse, where it could be different mix of them. And also depends what we can control or not. And then this is data warehouse. Data warehouse feels like everything together. We even don't notice it. We have storage, file format, table format, everything together. And now catalog, it's then you connect to Postgres with the Beaver, and you can see a list of databases and tables. This is your catalog. And then you run the query. Data stores inside Postgres some kind of like files, and they have the file format and the table format. But everything is own format of Postgres. And then Datalake. Datalake, as I said, it's decouple your storage and compute. And you can also now control what's your storage, what is your file format, what's your table format, what is your catalog. And the most popular table format and catalog is a hivemetastore. Even if you start Apache Spark locally and you create Spark SQL tables, it has the hivemetastore available for you to browse. The file format, the most popular is Parquet, and then the storage could be S3, HDFS, or some other kind of cloud storage. The benefits, it's cheaper. It stores the open formats. It means I don't like my compute, I can change my compute, but I have the data that I can transfer and connect to different tools. It's easier to work with unstructured data. You even can like store the videos and MP3 files. Performance, I don't know, depends, because you really care about how you partition data, how you query your data. It's limitations. Yeah, the performance is actually limitations, because you need to think how you're going to design your tables, your partitions, any other benefits that can help you. It requires lots of configurations. It has lack of acid transactions. By acid, it's big term, but the idea here is very simple example. In database, you can do delete, update, merge, or upsert. In data lake, no. In data lake, you can only, for example, drop partitions or overwrite partition. That's it. Or you can overwrite the whole table. Usually just append the data because it's the files. And if you want to delete the particular customer ID, you're not able to find what file has all the customers ID. That's why you operate on the files on partition layers or the whole table if it doesn't have partitions. And it's especially inconvenient with privacy and GDPR. When you need to run data lake or data warehouse, for me, my answer usually, I would run data warehouse because it's easier, faster, and it can handle this any volume of data. And if something doesn't fit into data warehouse pattern, I will use a data lake approach. For example, for some workloads, I can use Apache Spark, maybe manage Hadoop and process it, and then aggregate the data and write back to data warehouse. There my BI tools connect, because everyone knows how to work with SQL. Everyone knows how to connect to data warehouse, BI tools, and it's just convenient. Right now, our lakehouse platforms that we're moving towards, they kind of like mix both data lake and data warehouse. But you have a kind of like data lake with separated storage and compute, but it feels like data warehouse with convenience of SQL and how just everything works. Now we talk about data lakehouse. So it supports ACID. Now you can run your update delete commands. It has faster query because it just have more features. It has historical data snapshots, the same what I mentioned in Snowflake. Then you drop the data, change the data, you have still historical snapshot to recover. It's affordable architecture, probably reduce storage costs because you avoid duplication of data and avoid additional compute costs. Like, okay, better. And open architecture means that the same, if you don't like, today you can use Trino, tomorrow you can use Athena, and then you can jump to Databricks and back and forth. With Snowflake, you have vendor lock. You're not able to do anything about this. And here we example of all the same, right? All the same elements, but now we can talk, what is the table format? I just learned recently this word table format because in the past, I always confused table format and file format. For example, I can say the Parquet is a file format and Iceberg or Delta is a file format. That is wrong. The right answer, the Parquet is file format, but the Hive, Iceberg, Delta is a table format. That's the key distinction. This is just example how the things organized in Datalake or lakehouse. Imagine you have the folder, inside folder you have the files like your Parquet files, and this is your table. And the original file format that everyone using and still now using is the Hive, and it's by default for everything. But it has lots of limitations. And the hivemetastore, what is it? If I go in Snowflake, for example, and click here, I only can see the DDL, table DDL, that's it. But if I will do the same in Hive, assuming somewhere I have the Hive, and I will go and check DDL, Hive storing, this is the metadata. Hive storing the same metadata, but what it will store, do they have any? I'm looking that it will pointing to, doesn't have, it should point to location of the data. Oh, yeah, it's so many different parameters it has, I don't know. This is examples of Hive, and it has managed tables and external tables. Yeah, maybe with some point of time we need to actually go and do more tutorials on Hive. But here the idea that the Hive metastore, it's like your metastore or your catalog, it's the same as here. This is your catalog or metastore. Implementation of this could be very different. It has the metadata about your databases, schemas, and tables. It knows the table and points to the right location of the data. If we look to here, we have the table 1, then it's pointing to where the data files live, and it's know what to query. And the modern data lake table formats is Iceberg, Delta, and Hoodie, I think, is already not popular. Looks like the Apache Iceberg now is the most popular. Performance, easy to use, availability, scalability. What is it? It means it can, for example, you have 5 columns in the table and you ingest the file. After some time, your file has more than 5 columns, like 7 columns. Usually you need completely redo everything. You need to create new table, reload all data. But here availability means the schema evolution. So your table can adapt. If you have more columns, it will just extend, adding automatically new columns. And this is Apache Iceberg architecture. Here we still have the same like our Parquet files, but now we get a bunch of extra metadata files. In our catalog, then we have the table. It's pointing to the metadata file, and metadata file records the snapshots. It's pointing to the current snapshots of data. Then it also has the manifest list and the manifest files. If you ever will work with Iceberg tables, you go to S3 storage where your table is living. Inside folder, you will file like folder with parquets, but also you find the metadata files. And here we have examples of metadata files. Manifest files, they're starting from the bottom. Manifest file, list of data files, contain each data file's location path. So the manifest files tracks our data files, our parquet files, but also it knows the metadata about the file. For example, we know the size of parquet, we know number of rows, we know minimum and maximum values. We have lots of information about what's inside our parquet file, and this information is very helpful to create efficient query plan. Then is manifest file, manifest list. It's this one. Manifest list, it's defined a single snapshot of table as list of manifest files. This thing knows about manifest files because if you do some changes in data, you will create the new manifest file. And manifest list tracks those files, and you know what changes you have done with the table, but also it's pointing the most current one. And then the final one is metadata file. So the metadata file defines the table structure, including partition schema and list of snapshots, this one. And catalog, as I said, just list of tables and everything. Features of Apache Iceberg acidtransactions, partition evolution, hidden partition. So this is really nice. In Hive, if you ever work with Hive, well, then you work with Hive or anything like big data related technologies, you always need to have partition, because partitions you're storing in folders of files. The partitions, it's your subfolders. You can partition by days, by category. This is just your subfolders. And your primary goal, then you running your compute, you want to scan the least possible amount of data, the least possible number of files. Then you have partitions. For example, say I want to query last 7 days. If you partition by day, then you can just scan 7 folders instead of like 2 years of data. If you don't have partitions and you apply the filter last 7 days, you still will be scanning full thing, because the partitions like tip or about where is your data located. Without this, you will just scan the whole table, all the files, even if you specify the where condition. That's why the partitions is important. If you have last 7 days of data, it means you have 7 subfolders. And in Hive, it's very important that for partition column, you're using month. If you're using the where condition with, for example, here, they're using I forgot what they're using here, but if in Hive you're using month, first of all, if you partition by month, you have to add column month into your table. For example, you have date columns by default, and you want to partition by month. You first need to create the month column into your table, and then you will be able to partition by month. And also, if you want that partition works, you have to specify month column in your where condition. This is the Hive. You business users, they don't know about month, date. They will, I want last 2 months, and they will use the day column, and the partitions won't work because they not match like month, not match the day column. Hidden partition means if you partition by for example, here you can partition by, I don't know, day from order timestamp. But in your where condition, you can use order timestamp, or you can have the year time from order timestamp, doesn't matter. It's smart enough to understand the partition structure because it just works differently. And this is probably the most powerful feature. Row level table operations, I'm not good about them, like copy and write, merge and write. Time travel, we covered. The versions, the schema evolution. Here they have example of like, okay, what's happening with metadata files. By the way, they actually have the somewhere link to if we go to here, they have here examples. That's, for example, manifest file, manifest metadata file. What do we ever have? Also, this book is nice because it gives you a tutorial for running Iceberg on Spark and Dremio. If we go to here and we see what's inside this manifest file, this is metadata file. Our catalog pointing to metadata file. So it knows there's the living as free location. It's known then it was updated. It has the schema. So it's the schema of our table. It has information about snapshots. Then we have manifest list. This is manifest path. So it's storing in this file size. This is the versions of our manifest files. And then we have manifest file itself. It has information about our files, like our actual Parquet files with data, file format. It has information about partition. It has the column sizes, all like extra information about the things, boundaries, some additional, and all this information is very important when we query the data. And then you can now build, assuming the organization wants to build analytic solution. And the very first step, they can decide what storage system they want to use. Do they want to use data warehouse or they want to use big data stack? For me, big data stack is not about the volume of data, but it's about particular set of technologies like related to Hadoop, Spark, Hive, or like Datalake, and so on. The first organization should decide, okay, do we want to running traditional data warehouse with dbt, or we want to some kind of like big data solution close to data lake? But all data lakes now, they migrating to lakehouse. It means they only change their how they store the data. So from simple Parquet, they moving to Iceberg or Delta that give them more benefits. Then they need to decide. The examples of lakehouse, they're very popular, especially in open source, is Trino, and they call it. And by the way, the book, book created by Dremio. I think competitor of Trino. Trino is the query engine. This thing can run. It's open source. It can run the queries, and you can connect it to anything you want. And I don't know, do they have here example of architecture? Example, this company, what they have HDFS, means they're probably running on premise. They have HDFS as a storage managed by Hadoop cluster, and as a compute query thing, instead of Apache Spark, they're using Trino. And the data that they're storing in HDFS, it could be, for example, Parquet with the Iceberg. And here they probably can go and talk about different pros and cons, one Iceberg, and they compare it. The very first solution, many startup companies, they can use the Trino and the Iceberg. It will be your lakehouse. For example, in Databricks, you only will work, you can do still traditional data lake, but it's not worth it anymore now. In Databricks, you will do only lakehouse, and you will do either Delta Lake, Delta format that is default for Databricks, or you can now do Apache Iceberg. And the fun thing that creators of Delta Lake based in Databricks and the creators of Apache Iceberg, this guy was recently joined Databricks. So now the Databricks owning two, those like Lakehouse technology, Iceberg and Delta, and it's not sure what will happening next. And I think there is one technology, Apache Xtable, that's a kind like creating abstractions on top of Hoodie, Delta, and Iceberg. It's not yet very popular. People still like, okay, we either on Iceberg or Delta and Hoodie. And then it is clear there are two distinct use cases about Apache Iceberg and Lakehouse and Data Warehouse. The most interesting question, what will happen if in what scenarios you would like to mix it together. One of the potential scenario that exists, imagine the huge organizations, I don't know, some S&P 500 that already has multiple data warehouse. It might have Snowflake, it might have Databricks, it might have some other. So it's such big organizations that it has many different instances and different technologies. And then one part of organization running Snowflake and another part of organizations running Databricks. Then Databricks could be Deltalake or Iceberg. The Snowflake has own data format, but you need somehow connect them together. And one way of connecting it together using Iceberg Lakehouse. And the Snowflake, they basically invest into Iceberg. They choose the Iceberg. The Databricks choose the Iceberg. So everyone bet on Iceberg. And it has the Iceberg tables. You can think about, then we were here in our tutorial, and then we were pushing the data into Snowflake. It means we read the data and just push into Snowflake. With Iceberg idea that assuming you have the Databricks or Trino or some other kind of lakehouse, your data lives in S3 in the Iceberg format with parquets and everything, and you can query it with Athena, with Trino, with Databricks. In the past, you wasn't able to query this data with Snowflake because Snowflake is just closed thing and it works with itself. But now they gives you opportunity to use the Snowflake compute because you have your compute machines, right? Your warehouse that's running. Now it is able to connect to Iceberg catalog. And basically here you might have list of tables and databases. You can query them. It feels like it's Snowflake for business users, but physically under hood, you will query Iceberg tables that sits in S3. Now you will using the Snowflake only as a query engine. You don't use the Snowflake storage. And maybe down the road, some companies will prefer, okay, what the biggest disadvantage of Snowflake? It's vendor lock. If I'm starting using Snowflake, there is no way I can easily move away because I'm just vendor lock. Okay, it's the SQL, I can run the SQL, but all the data sits in Snowflake. How, if I have hundreds of terabytes of data inside Snowflake, how I gonna to extract it? It will be very expensive and very long job. Now, they probably shifting to the way, okay, if you don't like Snowflake, don't want to have this vendor lock experience with Snowflake to storing data inside Snowflake, you can actually store the data outside of Snowflake in the Iceberg format, in the open format, and then use only Snowflake compute to query the data. The Snowflake will work for you the same as a Spark or Trino or Athena. You have your data storage independent in the Iceberg format. You have your catalog with all your tables, metadata, and so on. And now you just bring your own compute with Snowflake. This is my perception. I don't know how it's gonna work because the challenge with this always with vendors, they over-promising. They give you, oh, it's such big idea. We're gonna do this and that to sell this idea to customers, but they couldn't change their behavior, and it's never happened. That's why to better understand this, there are a couple tutorials that we want to do. I actually also added a bunch of materials here that worth to read. They tells about why they're using Iceberg and so on. If you don't understand what Iceberg still, then I recommend you to invest time, especially if you're on data engineering track. Getting started with Iceberg tables, what we have here. If you want to do this, you can do. Okay, first it asks to working locally. I don't know, do we really need it or not? Because this thing, I can just copy paste it here into so I can go here and create new page. I can rename it. And you can, if you're in Snowflake, you can also go and do something. This is what I'm using. I will create the warehouse. I will create new role. I will create new database. I will create the schema, and I will grant all privileges. You did this, then it asks us to create the user. I can the user login name. I don't know, maybe it's case sensitive. Minus change disable, default warehouse, default namespace, default role. We can create this user. And now we can grant role to Iceberg Lab and to user. And I need to copy my username here. By the way, this is what we're doing right now. We're creating like permissions, objects in Snowflake, and we're doing it manually with commands. Alternative ways of doing this, oh no,
It's password.
Yeah, it's the user, definitely. Oh, maybe it's idea that it asks actually if we want to assign this role to our current user, then and for example, if our current user is this one, we just give this role with all the permissions to this user. Yeah, while I was talking. So how to manage in the right way permissions? There are some tools exist. One of them is permafrost, and maybe I need to add a project on this eventually because I'm using this in my work. This thing allows you to create YAML file. YAML file, there you can control all the permissions, right? The roles, the databases, who can do what. This word is important, role-based access control. This is how you control in databases, in BI tools, and this is permafrost. You have a kind of like YAML file. The downside of this thing, it's not able to create the objects. It's basically do grant, and then here you need to write what objects you have, what roles you have, and it will, when I say this, means this role will be grant, or this privilege will be granted to different databases. And it's very convenient because you can have define all your permissions in one place, and you can, if you want to change it, you will do it with a change request and pull request with code review, so everyone knows. Because without this, you have no idea, especially when you work a lot and many people, you have no idea what users, what roles has, what kind of permissions. It's literally impossible to track. It's such complicated. But here it has one big thing, and you have dry run. It means it will tell, okay, if you change something, it will tell what kind of permissions it will revoke or grant. As I said, the downside, it not able to create the objects. The alternative, Terraform Snowflake provider. This thing actually can control permissions, and you can create the objects. You can create, for example, you can create database, you can create the role, you can create anything, like exactly the same command as I say, create user, or create database, create, you can create, and then you can control the privileges. And it's work way faster, because downside of permafrost, it's very slow. Before actually doing anything, it will scan physically your Snowflake, like to pulling all objects. And imagine if you have lots and lots of users and objects, it could take 1 hour to just scanning and identifying what is changed. The Terraform, not scanning anything in Snowflake, it's actually trying to scanning the Terraform state. That is very fast, and then only comparing it with the commands you want to create. The Terraform is the better way, but yeah, because I didn't build this, I only use Terraform to create objects, and then I use permafrost to grant privileges. But yeah, obviously Terraform is better for everything. And there are some other, I think, in other tool calls I recently learned, Snowflake, maybe Titan. Or maybe yeah, this tool. Probably all the same, they just built nice UI for access control. And it also has the Python thing. Yeah, I think the Python also will work because Snowflake has the Python SDK, and it means you can do everything in Python. Okay. create everything we need. Now we want to create Iceberg table. Oh, we want to create external volume, right? And for external volume, it wants to have some kind of S3 access. First, I will create external volume. Let me moving it away. The most important thing to understand difference between data warehouse and a lakehouse. Yeah, and then that's probably the only most important thing to get out of this, because it's everywhere. For example, with hiring manager, you can have this discussion about pros and cons of data warehouse versus lakehouse and also Apache Iceberg. And you can come up with examples how in your organizations you tried Apache Iceberg as a proof of concept. I think this is probably the most up-to-date topic in data engineering right now.